Good afternoon. My name is Arjun Damaraju. I'm going to be talking about particle accelerators. A particle accelerator is a machine that uses electromagnetic fields to propel charged particles to very high speeds and energies and to contain them in well defined fields. Large accelerators are used for basic research in particle physics. The largest accelerator currently operating is the Large Hadron Collider near Geneva, Switzerland, operated by CERN. Electrostatic accelerators use static electric fields to accelerate particles. The most common types are the Cockcroft-Walton generator and the Van de Graaff generator. Small-scale exchange of this class is a cathode ray tube in an ordinary old television set. The achievable kinetic energy for particles in these devices is determined by the accelerating voltage, which is limited by electrical breakdown. For the most basic inquiries into the dynamics and structure of matter, space, and time, physicists seek the simplest kinds of interactions at the highest possible energies. These typically entail particle accelerators of many giga-electron volts and interactions of the simplest kinds of particles, like leptons colliding with leptons and leptons colliding with gluons. Since isolated quarks are unavailable due to color confinement, the simplest available experiments involve the interactions of tiny particles. Nuclear physicists and cosmologists may use beams of bare atomic nuclei, stripped of electrons, to investigate the structure, interaction, and properties of nuclei themselves and of condensed matter at extremely high temperatures and densities, such as might have occurred in the first moments of the Big Bang. Electron beam processing is commonly used for sterilization. Electron beams are on-off technology that provide a much higher dose rate than gamma or X-rays emitted by radioisotopes like cobalt-60, C60 or cesium-137, CS-137. Due to the higher dose rate, less exposure time is required and polymer degradation is reduced. Because electrons carry a charge, electron beams are less penetrating than both gamma and X-rays. The first accelerators used simple technology of a single static high voltage to accelerate charged particles. The charged particle was accelerated through an evacuated tube with an electrode at either end with a static potential across it. Since the particle passed only once through the potential difference, the output energy was limited to the accelerating voltage of the machine. While this method is still extremely popular today, with the electrostatic accelerators greatly outnumbering any other type, they are more suited to lower energy studies owing to the practical voltage limit of about 1 megavolt for air insulated machines or 30 megavolt when the accelerator is operated in a tank of pressurized gas with high dielectric strength such as sulfur hexafluoride. Electrodynamic accelerators can arise from either of two mechanisms: non resonant magnetic induction or resonant circuits, or cavities excited by oscillating RF fields. Magnetic induction accelerators accelerate particles by induction from an increasing magnetic field, as if the particles was the secondary winding in a transformer. The increasing magnetic field creates a circulating electric field, which can be configured to accelerate the particles' induction. Induction accelerators can be either linear or circular. Linear induction accelerators utilize ferrite-loaded, non-resistant induction cavities. Each cavity can be thought of as two large washer-shaped discs connected by an outer cylindrical tube. Between the discs is a ferrite toroid. A voltage pulse applied between the two discs causes an increasing magnetic field, which inductively couples power into the charged particle beam. The output of a particle accelerator can generally be directed towards multiple lines of experiments, one at a time, by means of a deviating electromagnet. This makes it possible to operate multiple experiments without needing to move things around or shutting down the entire accelerator beam. This is usually a fixed target, such as the phosphor coating on the back of the screen in the case of a television tube, a piece of uranium in an accelerator designed as a neutron source, or a tungsten target for an X-ray generator. In a linear, the target is simply fitted to the end of the accelerator. The particle tracks in a cyclotron is a spiral outwards from the center of the circular machine, so the accelerated particles emerge from a fixed point as for a linear accelerator. An accelerator operator controls the operations of a particle accelerator used in research experiments, reviews an experiment schedule to determine experiment parameters specified by an experimenter, adjusts particles between beam parameters such as aspect ratio, current intensity, and position on target, communicates with and assesses accelerator maintenance personnel to ensure readiness of support systems such as vacuum, magnet, power supplies, and controls, low conductivity water, LCW cooling, and radio frequency power supplies and controls. Additionally, the accelerator operator maintains a record of accelerator related events. Thank you.